Welcome back to part 23 of my DIY autonomous mobile robot building series. Today in part 23, using Fusion 360, we will create a hinge and pivot mount to allow the lid to open and close. If you're just joining us, be sure to check out parts 1 through 22. The links are in the description and the full playlist is at the end of this video. Okay, so moving on from part 22, go to the lid in the browser, right click and select Create Components from Bodies, which converts the lid body into its own component within the unspecified body part component. Speaking of which, let's rename unspecified body part to lower body parts. Hide body 2 and the remaining body of the lower body disappears. So our next task is to figure out how to mount the lid onto the chassis so that it can rotate on hinges. Let's rotate the design to the top view and select the top surface of the base surface of the HC SR04 holder, which lies on a plane that is parallel to the XY plane. Activate the lid component and create a new sketch. Select the XY plane, though the sketch will actually sit on the base surface of the HC SR04 holder rather than at the origin. Press P to project. Project the profile of battery pack rear hook 1, part of the profile of the upper component of battery pack rear hook 3. Project the center line and hit OK. Select the line tool and change the line type to construction. Sketch a horizontal construction line from the origin and set the length to 27 millimeters. Select the line tool again, change the line type to solid, and sketch a line from the end of the 27 millimeter line, perpendicular to the center line, to the inner projected line of battery pack rear hook 1. Then from the end of that line, sketch a 15 millimeter horizontal line. Then do the same at the lower side. Use the fillet tool to create a fillet at both corners and set the fillet radius to 5 millimeters. Then select the offset tool, select the U-shaped bracket we have just sketched, change the offset to negative 0.5 millimeters and hit OK. Then we just need to use the line tool to sketch 0.5 millimeter lines to close up each edge of the U-shaped bracket. Finish the sketch. Zoom up a bit, select the Extrude tool, select the section defined by the sketched U-shaped bracket, including the lower side too. Let's rotate the design to the side so that we can judge how far to extrude the U-shaped bracket. Drag the extrude arrow down until it passes through the lid. I settled on an extrude distance of negative 66 millimeters. We'll also need to change the operation in the extrude palette to new body instead of cut. Hit OK. Before we carry on, let's isolate the lower body parts by right-clicking and selecting Isolate. Open the Bodies folder inside the lid component in the browser, and if we hover the cursor over body 2, we can confirm that body 2 is the new extruded body. Next, select the Combine tool, select body 2 for the target body, and then the lid as the tool body. Leave the operation on cut and check Keep Tools so that the lid remains after the cut operation. Hit OK and body 2 is split into two bodies, body 2 and body 3. Hide body 3 and the excess material disappears, and let's have a look at the lid with our new bracket. Looking pretty good. So let's remove that body by right clicking and selecting Remove. Let's rename the body 2 folder Hinge Part. Now go back to the lower body parts folder, right click and unisolate. Activate the main design. We'll need to construct a hinge support, so select the outer face of the upper component of battery pack rear hook 3, and let's just open up the sketches and also activate this component. Looks like we need to select the outer face of the upper component of battery pack rear hook 3 again and create a new sketch. Press P to project. Project the face of the upper component of battery pack rear hook 3 and hit OK. Actually, the footage has jumped ahead a little bit, in which we have the circle tool already selected. This projected point seems like a good position for a through hole. Let's dimension that hole to a diameter of 2.2 millimeters, which we will use as a clearance hole for an M2 bolt. Let's zoom up for better visibility, sketch another circle at the same point, and dimension that circle to a diameter of 8 millimeters. Then finish the sketch. Tilt the design and select the Extrude tool. Select the non-extruded section defined between the two concentric circles and extrude by -3.7mm. The operation is already set to join, so we can just hit OK. Next, we need to cut the 2.2mm diameter hole, so unhide the sketch, select the extrude tool, select the remaining section in the 2.2mm diameter hole, set the extrude distance to -3.7mm, which automatically sets the operation to cut, and we can hit OK to perform the extrude or cut operation. Hide the sketch and turn the design around to the other side. Activate the main design and click on the canvas. Find outer wall 1 in the browser and hide it. Hide the lid for now. Select the outer face of battery pack rear hook 1 and scroll up to battery pack rear hook 1 in the browser and activate it. We might need to select the outer face of battery pack rear hook 1 again actually. Create a new sketch. We need to create a similar hinge on battery pack rear hook 1 as well, so press P to project and project the entire face of battery pack rear hook 1. Temporarily hide battery pack rear hook 1, project the upper component of battery pack rear hook 3, which has the hinge part. Hit OK and unhide battery pack rear hook 1. This is the curved portion that we'll be extruding, so finish the sketch, select the extrude tool, select the curved portion, extrude by -3.7mm and hit OK. Select the extrude tool, unhide the sketch, this time select the projected hole, extrude by -3.7mm and then hit OK to complete the operation. Here the footage has jumped ahead with the lid unhidden and the lower body parts activated. But we need to activate the lid itself, so let's activate the lid. Select the side of the hinge part and create a new sketch. Press P to project and project the 2.2mm diameter hole. I also projected this portion of the hinge part, but I don't think that was necessary. Anyway, go to the lid component in the browser, right click and select Isolate. Finish the sketch and tilt the lid a little. Select the extrude tool, select inside the projected 2.2mm diameter circle and extrude by -33.8mm, which looks like I have already measured the width of the hinge part off camera. Hit OK and there we have two holes formed through the left and right sides of the hinge part. Zoom up to a corner and select it. Select the fillet tool and create a 6mm fillet. Hit OK and do the same to the other corner at the other side. Now select the measure tool and measure the distance between the inner faces of the hinge part and we get a distance of 32.8mm. The footage has skipped a bit but nothing has been changed. Right click on the lid in the browser and select Unisolate. Let's just get the design into position. From Create, select New Component and label the new component Hinge Spacer. Hit OK and the new component is created. Right click on Hinge Spacer in the browser and select Isolate. Create a new sketch and select the YZ plane, although any plane would be fine. Select the circle tool, sketch a circle at the origin and give it a diameter of 2.2mm, which is the clearance diameter for an M2 bolt or screw. Select the circle tool again and sketch another circle, this time with a diameter of 3.7mm. Finish the sketch and tilt the design a bit. Select the extrude tool, select the area defined between the two circles and extrude by 15mm. Hit OK and there we have a spacer. Select the cylindrical surface, select the fillet tool and apply a 0.2mm fillet. Then press A for appearance and I applied a white pigment. Select the Move Copy tool and move the hinge spacer away from the origin. Right click on Hinge Spacer in the browser and unisolate it. Go to the top of the browser and activate the main design. So the hinge spacer is still inside the robot design. Select the Move Copy tool and move the hinge spacer rearward. We'll just reposition the design. Select Hinge Spacer in the browser again. Select the Move Copy tool. Select Create Copy in the palette and drag the copy from the original hinge spacer. Now select the lid in the browser, right click and isolate. Unhide the two hinge spaces also, the original and the copy. From Assemble, select Joint. Zoom up to the end of one of the hinge spaces. Select the central snap point at one end of the hinge spacer. Then select the central snap point at the inner side of one of the holes in the hinge part and the hinge spacer slides into place. Let's just reposition the lid, and I initially adjusted the lateral position of the hinge spacer spacer so that it was 1.4 millimeters away from the inner surface of the hinge part. However, I modified that distance to a closer distance of 0.4 millimeters. Because of that adjustment, I think we need to extend the length of the hinge spacer. Look for the extrude icon for the hinge spacer in the timeline. Right click and select Edit Feature. Since we moved the hinge spacer 1 millimeter closer to the hinge part, let's extend the extrude length to 16 millimeters and hit OK. Here I have measured the copy of the hinge spacer and it has automatically extended to the length of 16 millimeters also. Then attach the other hinge spacer to the other inner side of the hinge part in the same manner with a clearance of 0.4 millimeters. So there we have two 16 millimeter spacers which should work fine for a single bolt to pass through the hinge. Of course, a single 32 millimeter spacer would also do fine if available. Go to the lid in the browser, right click and unisolate. Let's turn the design back to the right way up and to the side a bit. Then scroll up to the joints folder, which, unlike in the footage, will be inside the relationships folder in the latest version of Fusion 360. Scroll down to the two last joints and I renamed them M2 spacer with hinge in parentheses. So let's right click on the lid in the browser and isolate it. Next, scroll up to battery pack rear hook 3 and unhide it. Go to assemble and select joint, and we'll actually need to momentarily hide battery pack rear hook 3 and select the central snap point of the hole in the hinge part. Then unhide battery pack rear hook 3 again and select the central snap point in the hinge hole at the inner side of battery pack rear hook 3. Let's just zoom out a bit and around to the side view. Then select the motion tab on the joint palette and change the motion type from rigid to revolute. This causes the lid to rotate by a full 360 degrees, so that will need adjusting. So let's set the minimum angle to 0 degrees, which is the initial position, and we'll try 80 degrees for the maximum position for now, and set the rest position to 0 degrees, equal to the minimum or initial position. Let's just preview the limits here. Initially that seems alright, although the lid is probably rotating up too high. Hit OK and go to Revolute joint in the joints folder. I renamed the Revolute joint to Lid Rotation. Right click on Lid Rotation and select Animate Joint. We'll need to take a closer look at the rotation of this lid. Right click on the lid in the browser and select Unisolate. Go to the lid rotation joint again, right click and select Animate Joint Relationships. Selecting Animate Joint would also result in the same action. Okay, as I think you can see, the front portion of the lid interferes with the chassis as it rotates. In other words, the rotating lid interferes with battery pack rear hooks 1 and 3. So go to the lid rotation joint, right click and select Edit Joint. Select the Motion tab, and we don't really know what angle the maximum angle should be changed to, so I just manually moved the rotational flag to rotate the lid to an angle that looks about right. In the footage, I'm actually moving the minimum position. That will need to be reset to 0 before the lid is animated. Firstly, if we rotate the lid to a maximum position that does not interfere with the chassis, then we can only rotate the lid by 20 degrees. But that amount of rotation would make it difficult to remove the 9-volt battery. So let's rotate the lid further. And I think 35 degrees is a sufficient amount of rotation, so let's settle on that angle. Tilt the design and you can see that the lid interferes a little with the chassis, or more specifically, battery pack rear hooks 1 and 3. Hit OK to leave the lid at that position for now. Here's a clearer view of the interference that occurs at the maximum opening angle of 35 degrees. Let's select the upper component of battery pack rear hook 3 so that it is easier to find in the browser. Scroll down and activate battery pack rear hook 3. I'll just open up the folder here. Select the upper component of battery pack rear hook 3 again and create a new sketch. Get the sketch into position and zoom up a bit. Press P to project the edge profiles of the front of the lid, and project the outer face of the upper component of battery pack rear hook 3. Hit OK. Select the circle tool, sketch a circle centered at the top left projected point of the left rectangular slot and give it a diameter of 7 millimeters. Select the circle tool again and sketch a circle at an arbitrary position around where the lid interferes with the chassis, and I initially set it to a diameter of 20 millimeters. Select the coincident tool and make the circle coincident with this projected point near the hinge. Now select the tangent tool and make the 20 millimeter diameter circle tangent with the 7 millimeter diameter circle. Also, I ended up reducing the diameter of the 20 millimeter circle down to 15 millimeters. Select the circle tool again, sketch a 4 millimeter diameter circle at an arbitrary position, move the circle between the 15 millimeter diameter circle and the 7 millimeter diameter circle. Select the coincident tool, select this projected point so that the 4 millimeter diameter circle becomes coincident with the projected point. Then select the tangent tool, select the 4 millimeter diameter circle and the 15 millimeter diameter circle to make these circles tangent with each other. We'll need to remove these projected interfering line segments of the lid. So right click on each interfering line segment and select delete to remove. So here the footage has skipped ahead a little with the design tilted, ready for the cut operation. To avoid cutting a notch out of the lid during the cut operation, we should isolate battery pack rear hook 3 first. Select the extrude tool, select the portion defined by the 15 millimeter diameter circle and also the portion at the corner defined between the 15 millimeter diameter circle, the 4 millimeter diameter circle and the top surface. Extrude by -3.7 millimeters, hit OK, and there we have a concave cutout in the upper component of battery pack rear hook 3. Right click on battery pack rear hook 3 in the browser and select unisolate. Then scroll up to the top of the browser and activate the main design. Let's take another close look at the relationship between the lid and the concave cutout. And we can see that there is no mutual interference. So let's turn the design to the other side and create the same concave cut in battery pack rear hook 1. Scroll down to battery pack rear hook 1 in the browser, activate it, expand the folders, right click and isolate. Scroll down to battery pack rear hook 3 in the browser and unhide it, though it isn't very visible because battery pack rear hook 1 is activated. Select the outer face of battery pack rear hook 1 and create a new sketch. Press P to project and let's temporarily hide battery pack rear hook 1 and project the profile of the upper component of battery pack rear hook 3. Unhide battery pack rear hook 1 again and then project its profile. Hit OK. Finish the sketch, tilt the design, select the extrude tool, select the projected concave portion and extrude by -3.7 millimeters. And there we have the concave portion cut out. Go to battery pack rear hook 1 in the browser, right click and select unisolate. Scroll up to the top of the browser and activate the main design. And there we have successfully modified the chassis to accommodate the rotation of the lid to a 35-degree angle. Scroll down to the lid rotation revolute joint, right click and select edit joint. Select the motion tab on the edit joint palette, set the minimum angle back to 0 degrees, set the maximum angle to 35 degrees and rest to 0. Go back to the lid rotation revolute joint, right click and select animate joint relationships. And there the lid starts to rotate open and shut without interfering with the chassis. Opening this lid allows the 9-volt battery to be accessed and also allows a cable to be connected to the Arduino UNO. Let's scroll down to the lower body parts and unhide the remainder of the body, which is just called body 2 at the moment, and there we can see the lid in action rotating relative to the lower body. Click here for part 24. If the link isn't showing, part 24 isn't quite ready but should be soon. Check the description for my upload schedule. Thank you for watching.